Camp Pendleton, California. Here, young Marines hone the skills critical to success on the battlefield. Many train for missions we've come to recognize as the role of the U.S. Marine Corps. But others train for a different mission, one far less familiar but equally as vital. Platoon Charlie Company. These are the first combat engineers of the U.S. Marine Corps. Like any Marine, their job is to defend freedom at a moment's notice. But unlike their brothers who use high-tech weaponry to deliver the deadly blow of high explosives, these men face a more immediate task, the application of explosives by hand. Their job? Blow the bridge, trench the road, or mine the field.
On this bottom fuselage right here, for anti-handling device.
Basically what we do, depending on what unit you're in, your construction work and demolition work. You work with building land fortifications as far as obstacles, and then demolition work is working with explosives, blowing up things. A lot of times, if you're lucky, you get to build something and blow it up.
The combat engineer's job is to be as complete and diverse a Marine as the battlefield can utilize. In addition to the traditional skills of warfare, they must handle tricky and delicate explosive devices. They are expected to be the first in and the last out of a fight. They must be cool under fire and have nerves of steel. And they are expected to handle sufficient explosives to stop an enemy platoon, or their own, if they are not careful.
When this detonates, this actually inverts with the heat and the energy. What happens, it's like this. When it detonates, it just blows straight down. That's all it does. And the heat and the energy, the force goes straight into the ground. Okay, I think you might have got it.
Today's high explosive carries complex chemical designations such as RDX, HBX1, and tetryl. But most are basically nitrate-based compounds mixed with inert moderators to make them more stable. They require a severe shock or detonation to unleash their immense power.
The type of explosives that we use, there's a variety of them. It depends on the job that we're going to do. We use a plastic explosive called C-4, used for breaching and cutting. We use TNT for like pushing stumps, doing dirt removal. We're going to make tank ditches. We have mines that we use to stop and channelize vehicles and personnel.
Today, these Marines are rigging explosives on simulated targets. Each device does a different job, but all are designed to assist the Marines in carrying out their combat duties. When the fuses are set and the troops withdrawn, it is time to test their handiwork. All explosive weapons can trace their lineage to the invention of that simple but destructive chemical compound, gunpowder. The invention of gunpowder was the single most important advance in the annals of warfare. It began in ancient China.
The rocket was probably one of the very first applications of after the invention of black powder, propellant as it's now known, or gunpowder. The idea very basically was that as the black powder burnt, the forward motion carried a small canister with some sort of tail providing stabilization. The Chinese were always quoted as the first users of these things. From them came the Indians, who showed the British what rockets were, and from them the British went on to develop quite sophisticated war rockets of their own, Napier and Hale rockets, for instance.
In 1867, the Swedish inventor Alfred Nobel combined nitroglycerin with wood pulp to produce dynamite. The Europeans rapidly developed large guns to propel high explosives as far as possible.
The Industrial Revolution made possible great advances in the manufacture of refined steels that size, volume for volume, were much stronger and much lighter than the old wrought iron and other materials that had been used before. So that guns became stronger, but at the same time, size for size, they became lighter. So you could build much larger and larger guns that could withstand greater internal pressures. And the greater the internal pressure, the faster the shot came out of the hole at the end, and the further it could be fired.
By the early 20th century, exploding projectiles with timed fuses had been sufficiently refined that they yielded much higher casualties than their predecessors. But it would take one more critical development to bring artillery into the 20th century: rifling.
What that in fact is, it's grooves inside the barrel that twist the projectile as it is pushed down the barrel. Now this twist makes the projectile spin, and so therefore it stays much more stable in flight for much longer. You can therefore you point a gun at a target with a pretty fair realization you're going to hit it. And what also happened was that to make the projectile even more stable, they became longer, they became elongated. So instead of the round cannonball, the projectile was longer. We came to the sort of the classic shell type shape that we came now. That shape spins, and as it's longer, you can pack more explosive into it, so it actually hit the target, but with a far more destructive bang.
A single large shell could now do the work of dozens of older projectiles. By the First World War, weapons of unprecedented size were being developed. The largest and most infamous was the Paris gun. This German weapon fired huge 228-pound shells into downtown Paris from well behind German lines.
It consisted of a very, very, very long gun barrel. I think it was about 156 calibers long, whereas most guns at the time were 30 or 40 calibers was long. And from a range of 72 miles and hidden away in a forest, it could literally rain shells on Paris. That was the idea.
As artillery became larger and less mobile, it was also more vulnerable to a new use of high explosives, the delivery of bombs from the air.
World War I, we used a lot of bombs delivered by aircraft. What was beyond the range of an artillery piece and needed more accuracy, we had to carry in an aircraft. Drop the bombs from a World War I aircraft to extend the range beyond where the forces were.
So we take 3-inch shell casings and just chunk them full of all kinds of stuff, everything we could put in there, and make our own bombs, seal them up, put the fuse in. We'd get over a road, we'd see a line of trucks. So we'd try to work out our windage, and we'd let them go, see. And then we'd fire them back, and we'd try to watch the trajectory as they dropped. And sometimes we'd be 200 or 300 yards off target. After you did it maybe 3 or 4 times, you got pretty good where you could come pretty close to it.
During World War I, bombs grew from 5 pounds to over 500, and the planes of the era could carry up to 2,000 pounds of them. Aerial bombing was here to stay. While gunpowder had powered the military machines of the world for centuries, a new and more powerful explosive was finding a home on the world's battlefields. Based on coal oil, TNT was part of a new breed of chemical, the high explosive. High explosives burn at hypersonic speeds. The gases released then form deadly shock waves that shear and shatter anything in their path. This enhanced destructiveness soon migrated from the battlefields of Europe to the sea. The First World War found floating battle wagons of unprecedented size. On these enormous ships were guns larger than ever seen at sea. The shells fired by the big 14-inch naval guns were huge, weighing nearly a ton. They could be fired up to 9 miles with ravaging effects. Large crews were needed to handle the enormous explosives.
Projectiles arrived inverted on the upper hoist in a shell car. When they reached the top, they were tilted backwards onto a transfer tray and rolled onto the loading tray, where they were then rammed into the weapon. Once the projectile had been seated, powder bags were passed up from the gun pit below in groups of 2. They were placed on the rammer tray and rammed in by a team of 2 men using a wooden pole. Once all 4 bags, or 420 pounds of powder, had been loaded, the breech was swung closed and a cartridge was placed in the firing mechanism for the subsequent round. About 16 men operated this level of the turret. Temperatures in here could raise to approximately 120 degrees.
While naval artillery claimed victories on the surface, the balance of power was shifting to explosives fired from beneath the waves.
Most of the submarine technology in the First World War was very low technology. It was really a matter of putting explosives into a tin fish and sending it out propelled by compressed air with a contact detonator which exploded when it contacted something.
This silent killer, packing up to 500 pounds of TNT, was a new twist in the stealthy delivery of high explosives and shook the navies of the world to their core. From nearly 3/4 of a mile away, a submarine could sink the largest ship with impunity. Back on land, it was not large explosives, but the rapid-fire machine gun that was revolutionizing warfare.
The First World War was really dominated by the machine gun and the trench, and very high casualties. A 2 or 3 man team could put a large amount of firepower down very quickly. If you had lots of machine guns, the infantry could not really move because there was so much firepower there.
The advent of stable explosive powders allowed for the development of rapid-fire weapons. Hundreds of bullets could be fired in just minutes from a single gun. Particularly deadly was the British Vickers heavy machine gun, capable of a sustained rate of fire of 10,000 rounds per hour. Produced from 1912 to 1966, it was one of the most enduring designs of the century. Machine guns brought the trench war to a standstill. It would take one more technological advance to break the stalemate of the Great War.
First tank as we know it really evolved during the First World War. In the early days of the war, the Allied forces did use armoured cars, but as the static situation developed, trenches, barbed wire, obviously armoured cars could not cross this type of terrain. So tanks were developed in order to cross a terrain swept by machine gun fire, covered in barbed wire and covered in very deep trenches.
The tank could resist the terror of the machine gun and carry its own high-explosive weapon into the heart of the enemy. The tank helped bring an Allied victory, but the resulting peace would last less than 20 years. As Germany broke out of its interwar confines in the late 30s, other nations looked at their own military resources and found them sorely lacking. The largest war of all time was coming, and it was to be the absolute height of the use of high explosives in human history. Millions of tons would be used in anger, causing damage on a scale scarcely imagined just 2 decades earlier. While most of the world had developed their weaponry little since the First World War, the Germans had not been so complacent.
By the time the Second World War came around in 1939, most of the Allied nations were still using the guns they were using in the First World War. Now, the nation that was perhaps best situated in 1939 for a modern artillery war was Germany, because after 1918, the Treaty of Versailles virtually removed all the artillery they had. So they were free in clandestine conditions to develop a whole new family of artillery. And by 1939, they were well on the way to producing those guns in great numbers, which is what modern war requires, not just modern guns, but large numbers as well. And the Allies had a heck of a job to actually try and catch up with them.
But by 1942, America's superior mass production skills enabled the Allies to counter the German guns through sheer numbers.
World War II was the apex or the high point as far as the artillery.
use in our history. And the reason it was not because we had that much better weapons or that much better ammunition, but it was because we were very flexible. And the main thing is we could mass our fires from many locations. We could sometimes put 8, 10, 20, 30 battalions on some of the critical targets. This is something that most of the other artilleries couldn't do.
Improved tactics required the modernization of the fuses for the shells to maximize the explosive effects.
Prior to World War II, we had the time fuse. And that was a fuse that you set on the head of the projectile, and you turned it like a clock and you set the time on it. When you fired it out there, you set the time according to the range. You wanted it to burst at a certain point. In most cases, inaccurate.
The proximity fuse was a new and deadly advance in shell design. Sensing the distance to the ground with radio waves, it would explode at a predetermined altitude set to inflict the maximum damage on the target below. The Allies continued to modernize their arsenal. But the foot soldier armed with only a rifle was no match for German armor. As artillery improved, designers concentrated on portable high-explosive weapons for the infantry. The mortar, lobbing a 7-pound charge up to 3,300 yards, was a deadly weapon that carried small artillery into the field with the individual. The hand grenade packed 4 ounces of black powder into a fragmenting case that could kill combatants 75 feet away. Satchel charges, used widely in the Pacific War against Japan, packed up to 40 pounds of TNT into a small package. They were a mainstay of the combat engineers who used them with devastating effect. And the bazooka, which could dispatch a 3-pound explosive charge with rocket propulsion to penetrate up to 6 inches of enemy armor. The bazooka was the ingenious invention of an ordnance officer at the Aberdeen Proving Grounds. The finned rocket was tipped with a shaped charge, a hollow cone of explosive focused into a jet of hot gas at high velocity that melted a hole through armor plate. The use of these improved weapons blunted the German land offensive in Europe. And behind enemy lines were the fighters of the American Office of Strategic Services, or OSS. These brave men specialized in covert demolition, which slowed the German war machine.
We had regular demolitions to use, to blow bridges, to blow culverts, to create incendiary fires, blow up ammunition dumps. We had time pencils that would time a discharge of an explosion from anywhere to 15 minutes to 2 hours. So we could be well away from the target before it blew.
The German onslaught could be slowed, but not stopped. New high-tech weapons would be unleashed against the Allies, and a terrifying sound would soon fill British skies. Explosive force delivered as far and as accurately as possible. In 1943, the Germans evolved this theorem to a new and shattering climax. The 25-foot-long V-1 was a crude guided bomb. By 1943, these ramjets were dropping 2,000-pound warheads into downtown London.
Those were obviously very large. They were made for surface-to-surface application, launched from the surface of the Earth, exploded on the surface of the Earth, carried very large warheads. Their intent was to destroy buildings, cities, large areas. They were fairly inaccurate. They couldn't pick the building, they couldn't pick the block where they'd land, but they could probably pick the city where they would hit.
The Allies soon learned the weakness of the V-1. It could easily be shot down. It ceased to be an effective weapon. But Hitler was not so easily foiled, and the search for more accurate and immediate ways to drop explosives on the Londoners became an obsession.
The V2 carried about a 1-ton warhead over about 200 miles. In those days, in the date 1944 and 1945, when it was used operationally, it was a considerable advance on anything that had gone before. The only way of defending anywhere against the V2 was to hit it when it was still on the ground before it was launched, which was very, very difficult to do, because it was difficult to find in the small targets.
The V2 was the first intercontinental rocket to carry explosives. Complex and expensive to build, the 5,000 that were launched at Allied cities brought terrifying results. In sharp contrast to these high-tech rockets, the Germans also relied upon simple landmines to slow the Allied advance. Large anti-tank mines designed to stop Allied armor were usually used in combination with anti-personnel mines.
To prevent engineers from lifting the anti-tank mine, anti-personnel mines have been developed. The purpose of the anti-personnel mine was not to kill, but to maim, to impose a burden upon the enemy's logistics system. Wounded men needed to be evacuated.
To counter this gruesome threat and keep the forces moving forward, the Allies developed several methods for clearing mines. The most reliable method was to clear the area by hand while on the ground to avoid enemy fire. The engineer used a bayonet to probe the ground. Once something metallic was encountered, the engineer would find the edges and carefully dig up the mine.
Generally, we sent teams in there. You usually worked in pairs, and you wanted to know who you were working with pretty well. And most of the time, we tried not to leave any pair in more than about 30 minutes because it really get pretty nervous, and they had a hard time doing it.
When the area was not covered by German fire, metal-detecting minesweepers could be used. But as the Allied mine-breaching methods became more efficient, the Germans countered with more ingenious mines.
Early metal mines were comparatively easy to detect by the mechanical methods then employed by the Allies. The Germans developed the plastic and indeed wooden mines, which were far more difficult to detect and hence more deadly.
The most common of the wooden mines was a small anti-personnel device known as the shoe mine, which contained a half-pound charge, a detonator, and a fuse. Because of its small size, it could be hidden in a variety of places and was still capable of taking off a foot when stepped on. In the air, the Allies were staging 1,000-plane raids over Germany and Tokyo, where over 3 million pounds of bombs could be delivered in a single raid. And in the sea, both the Atlantic and the Pacific, more accurate torpedoes blew apart new ships. And larger battleships capable of firing 2,000-pound shells over 20 miles. Back on the soil of Europe, the ultimate expression of conventional artillery was firing at Allied targets.
It was the biggest gun of all time, and that's the sole reason why it was built. It was a Wagnerian obsession by Hitler and the Nazi regime to have something that was bigger, that would really be absolutely the greatest gun of all time. And it was a whopper. The shells were taller than a man. The caliber, the actual width of the barrel was 800 millimeters. But in military terms, it was laughable, because the actual resources to actually make the gun were such that you could have used the same resources, material, manpower and everything else to virtually arm a division of panzers.
While the huge gun was a logistical failure, its effect on the Allies was profound.
The
sound of that shell coming in, I'll never forget. It sounded like a boxcar coming through the air sideways, but it was a demoralizing gun. Just to hear that thing fired would cause you all kinds of heartburn.
The search for bigger guns packing a more powerful punch reached its staggering climax in World War II. Until the final, most devastating weapon of them all took the crown away from conventional explosives.
Someone had said something about this bomb that was so powerful that none of us could imagine such power, because we were accustomed to the grenades and the mortars and the TNT that we'd put together to blow up things. And it was hard to believe until we got to Nagasaki. And here was this city completely wiped out. It was nothing but rubbles of concrete. There were cornerstones of buildings around, but no buildings to sit on them.
In a moment, the history of high explosives was forever rewritten, and warfare would never be the same. The awesome bombs carried the punch of thousands and later millions of tons of conventional explosive. They were so powerful that a new measure of explosive force was invented, the kiloton, equal to 1,000 tons of TNT. The million-pound equivalent, the megaton, was later added to the books. The Hiroshima bomb was equivalent to 15,000 tons of TNT, or 15 kilotons. Tests confirmed the shocking numbers.
What they were basically trying to do is to find out exactly what sort of genie they'd actually unleashed from the bottle. What they really wanted to know was what sort of empirical data could they gain from this device. Actually, how powerful was it? What effects would it have? How far would the fallout go? What effects would it have on targets on the ground? They used warships. But they also had measurement devices on the atolls to measure the blast, to measure the damage inflicted, to work out what sort of casualties they would actually produce.
Nuclear weapons were so total in their destructive potential, many thought that the days of conventional bombs and bombers were gone forever. But then the United States was dragged into yet another military engagement, the Korean War. It was a limited war with limited goals. And with both Soviet and American nuclear arsenals at the ready, UN planners felt that the possibility of an all-out atomic war was too awful to risk. The conventional weapons of yesterday would again be brought out.
By the time of the Korean War, artillery wasn't much advanced than it had been in 1939. The artillery strategy was such that we were almost back to the Great War in many ways, because the nature of the terrain in Korea meant that you couldn't use armor. Ordinary conventional towed artillery was used most of the time. And artillery just went back to the days of the Great War. It was trench warfare all over again.
Traditional high explosives powered the U.S. war machine in its relentless assault against North Korea. The huge stockpiles left from World War II were brought into the conflict. Though the atomic bombs were left in storage during Korea, the development of nuclear weapons, the final word in explosives, went on. But America held a monopoly on the power of the atom for just 3 years. Then, in 1948, the Soviet Union tested their first atomic device, and the nuclear arms race was underway. The testing of the first hydrogen bomb upped the ante. With new weapons 5 million times more powerful than the Hiroshima bomb, the priority was to find a way to deliver them to the heart of Russia. Whereas vast fleets of bombers were available in World War II, the Cold War found small numbers of nuclear bombers, but they had to be big, fast, and able to penetrate hostile Soviet airspace.
In the 1950s, it was decided that the best way of carrying the nuclear weapon, the ultimate strategic deterrent, was to carry it in bomber aircraft. American bomber technology had reached a pinnacle with the 8-engine B-52, the Stratofortress. It's the classic American post-war bomber.
Soon, small fleets of B-52s, half of which were in the air at any given time, were ready to defend U.S. soil in the event of a Soviet attack. But an even faster and more deadly method of attack was in development. The intercontinental ballistic missile could vaporize a Russian city in under 20 minutes. Falling from space at supersonic speeds, it was an unstoppable terror. But even as plans for atomic war on a vast scale were being drawn up, ideas were also being considered for smaller, more limited nuclear engagements.
Atomic Annie was a 240mm gun produced in the United States during the 1950s. It was unusual in design. It had a twin tractor unit, but the main difference was, as far as the gun was concerned, it fired an atomic projectile. It was just an oversized gun. In fact, it was so big and so heavy, it was difficult to move, and it fell out into disuse, not because it was an atomic gun, but because it was such a bitch to move.
The search resumed for stealthier, more mobile ways to deliver a nuclear punch. The superpowers turned again to the submarine.
They are equipped with the latest technology in terms of computers, in terms of sonar systems, listening devices, and in weapon systems. Not only do they carry torpedoes, they also carry missiles which can be launched submerged to attack surface targets. They're an all-round weapon system. They're the capital ships of the conventional Navy.
Able to launch just offshore from the Soviet Union, a single American submarine could now launch a missile attack equivalent to almost 140,000 fully loaded B-17 bombers. It was the single most destabilizing development of the Cold War. When the United States entered the war in Vietnam, it found itself in an all-too-familiar place. Caught in a regional undeclared war, it had to restrain its nuclear might and return to the use of conventional weapons. Once more, high-explosive bombs, shells, and explosives would go to war. For the wholesale delivery of explosives, the B-52 nuclear bomber was assigned to a new role, and soon the Stratofortress was used in anger for the first time. Able to carry over 70,000 pounds of conventional high-explosive bombs, the Mammoth planes delivered more explosives to North Vietnam than were dropped on all of Europe during the Second World War.
It's devastating. A good box will kill everything in it for a distance of 1 mile in length and 1,500 feet wide. 324 weapons in that area in 15 seconds. For an enemy infantryman on the ground, it was absolutely, positively a terrorist weapon. It had to be a terrorist weapon because they couldn't hear us. All they could hear would be 5 seconds before impact, the scream of the bombs coming down. And so the impact would occur before they could even take a breath.
But it was one unique conventional bomb that was the climax of high explosives in Vietnam. Called Big Blue 82, it was a blockbuster that caused injuries for miles. At 15,000 pounds, a single bomb was the entire cargo for the journey into hostile airspace. Delivered from the hold of a C-130 cargo plane, the bomb was slowed by a parachute and drifted to its target. When it exploded, the crater was enormous and the destruction total. It remains the single largest conventional bomb dropped on enemy forces at any time. When the United States rushed to rescue tiny Kuwait from an Iraqi attack in 1990, the precise delivery of a staggering array of high explosives was key to success. Once again, the doomsday weapons were left in their silos. This war would be won with the ultra-accurate long-range delivery of conventional weapons deep behind enemy lines. Tomahawk cruise missiles epitomize the high-tech long-range weapon.
In the Gulf War of 1991, we launched almost 300 land attack Tomahawk missiles. They proved very effective. The Tomahawks came across the countryside at 20, 30 feet, at only a few hundred miles an hour. And they could actually see and even photograph the Tomahawks coming down the roads. As the missile flies over the land, its radar looks down, compares the terrain with what's on its digitized tape. When they match, it knows it's going the right direction. Once the missile electronically sights its target, it then uses another guidance system which cuts in and guides it to within literally a few feet of the aim point.
Along with the Tomahawk, smart bombs dropped from F-117 stealth fighters knocked out high-priority targets with surgical accuracy. The delivery of high explosives had reached a new and unprecedented level of precision.
3, 2, 1, impact. Boom! There's a hit. There's a shack. And, oh yeah. Secondaries. Big time secondaries.
Smart bombs are guided to their targets via a laser beam from the attacking aircraft. Correcting its trajectory as it falls, it is able to home into within a few feet of its designated point of impact. No site in Iraq was safe, as America owned the skies. In contrast to these high-tech weapons, the MLRS, or Multiple Launch Rocket System, gave new life to the unguided rocket. This distant relative of the ancient Chinese rocket depends less on pinpoint accuracy and more on massive firepower. The 8-inch diameter rockets it fires each carry 600 bomblets in their warhead. One rocket can cover a football field-sized area with instant devastation.
It's a complement to artillery, but it is a counter-battery weapon. Or an interdiction weapon. It can fire rockets over 30 kilometers and cover large areas. You can knock out an enemy battery. You can knock out the supply area. You can knock out tanks when they're still in the formation stage before they make an attack.
But even in this age of high-tech massive firepower, there is no replacement for the accuracy of hand-placed high explosives. It is for this role that the Marines of Camp Pendleton train daily. Today, Charlie Company will attempt to take out a simulated enemy position with high explosives.
There's a bunker or objective on top of a hill, and we got to assault through some barriers of concertina wire and barbed wire and engineer stakes and rough terrain to get to the objective to take out the objective.
The objective? A hilltop fortification surrounded by trenches and barbed wire. Bangalore torpedoes. Joined sections of pipe filled with high explosives are inserted through the barbed wire obstacles under the cover of smoke grenades. Second squad moves up, laying 40-pound satchel charges to clear the last ramparts of enemy resistance. Finally, the objective is taken and the exercise complete. This sort of training paid dividends in Desert Storm, where the munitions men still had a job to do.
One squad would go to a bunker, and then we would come up real slow first, and then we check it out, look inside the bunker. We find any munitions inside the bunker, make sure there isn't any prisoners, any prisoners in there, or any soldiers. And then sometimes we use grenades, sometimes we use satchel charges. We'll go in and we'll prime up some explosives and we'll blow it in place. We go from bunker to bunker.
Desert Storm was the zenith of the fast, ultra-accurate delivery of both large and small amounts of chemical explosives. It was a reminder that large-scale conventional warfare is still a possibility, and one that must be prepared for.